Alright, I'd like to talk about the concepts behind tangent line approximations, sometimes also referred to as linearization. So this isn't going to be an example. I'll have an example in another video. This is just kind of the idea behind what's going on here. So let's just say I were to make some graph. Okay, let's say it looked like that. Okay, so call it f of x. Okay, so some function f of x. The idea is that if you were to make a tangent line to this graph at some point, let's say I make it right here at this point, okay? So a tangent line, remember, touches the graph at that point and has the same slope. The idea behind a tangent line approximation is that if you stay close to the point of tangency, let's call that x equals a, the y value on the tangent line and the y value on your function are close, are very similar. You know, notice if you look right here, the y value on the tangent line and the y value on the graph are very, very close to one another. Again, this is if you're very close, if you stay close enough to your point of tangency. Okay? You can see, of course, as you get farther away, you know, isn't the case anymore. As we're further away now, you can see that the y value on the actual function is not that close to the y value on the tangent line. But there are certain types of equations that, without a calculator, which we have nowadays, so this isn't going to come in as handy as it would have a long time ago, say like a square root function, for instance. You know, we don't know all the square root values off the top of our head. There's some that are simple, like say square root of 4. That's an easy one, okay? But square root of 4.1 or 4.2 is not easy for us to figure out. So you could use a tangent line approximation to, you know, get a good idea of what the value of that looks like. And the idea behind that is, you know, you have your actual function, whether it be a square root function, which obviously doesn't look like this, or a sine wave, or some type of function that you aren't able to just easily, you know, figure out what the value is, okay? Because you know, sine functions, square root functions, you know, don't operate like, you know, functions just like x plus 2, okay? If you know a value that's close, like say, so for instance, I said square root of 4.1, that's a value we don't know, but we know square root of 4. So if you know a value that's close by, you can make a tangent line at that value, and what you can do is you can basically, you know, you'd love to have the actual value on the function. So the actual value on the function, I'm talking about that value up there. I'm hoping you can see that little dot that I have right there. That's the value that we want, let's say at like 4.1 or, you know, a value that's close to a. But we can, you know, because we know it's so close and we aren't able to get that actual value, we can use the tangent line approximation and we can actually get this value instead, which sure is not the correct value that we want, but it's close. It's an approximation. Okay. Now, you know, we can't get, you know, something. So if we wanted, let's say, square root of like, you know, 7 or something like that. Okay. Well, we know that square root of 7 is going to be tough to get because that's quite a ways away from square root of 4. You know, using that same tangent line. So you have to have a certain point, you know, kind of close by that you're going to use there. So basically what you would do is you just plug in, so let's just say you have some value like b, okay, that's close to a here. What you would do is you know, ideally you would want to plug b into your function to get the actual y value on the function, but since we aren't able to do that in these cases, as you'll see in the next example, what I would do is I would take that value b and plug it into the tangent line and come up with the y value that's actually on the tangent line, which is close to the actual y value on the function. So if this was confusing, I'm sorry, but hopefully in the next example it'll be a little bit clearer.